So in this video, we're going to talk about how do you simplify complex fractions. And there's a couple of ways that you can do this. But since we've been working with common denominators, that's the method we're going to utilize here. And it makes it very easy, okay? So what we're going to do is we are going to examine the complex fraction. When I say a complex fraction, it means a large fraction in which there's at least one other fraction. So I might have a fraction in the denominator and or a fraction in the numerator. That's what's considered a complex fraction. So what we're going to do is we're going to look at the fractions in the numerator and the denominator, and we're going to focus our attention on the denominators of those fractions. And we are going to think about what is the least common denominator of 7 and 14. Okay? Least common multiple of those two numbers, and that would be 14, right? Okay, so what we're going to do is we're going to take this 2 over 7 and this 5 over 14, and we're going to multiply both of them by 14. Okay, so we're going to multiply this by 14, and we're going to multiply this by 14. Okay, notice that this 14 is really like in a numerator, so I can simplify this. 14 over 7 is the same as 2 over 1, so this just becomes a 2, and the whole numerator simplifies to a 4. And notice in the denominator, we have a 14 over 14, and so those divide out, and I'm just left with 5. And so this whole thing over here simplifies to just 4 over 5. Now, if you have just a complex fraction with just numbers, or just 2, or just in the numerator there's one fraction and in the denominator there's another fraction, you can just rewrite this as a division problem, and you can say this is 2/7 divided by 5 over 14, which is the same as 2 over 7 multiplied by 14 over 5. Just like we did before, we can notice that this 7 and the 14 is the same as 2 over 1. And then if I multiply that through, I've got 2 times 2, which is 4. And 5 times 1 in the denominator is 5. Another way to get to the same answer. However, this only works when you have a single fraction in the numerator divided by a single fraction in the denominator. When you've got multiple things going on like we do here and here, we can't actually use that process. So let's think about this next one. I am looking for the least common denominator of, let's see, I've got an 8x, I've got a 2, this is a 1, and I've got a 4x. Okay, so what can I turn all of these into? What's the least common denominator there? Well, it's definitely going to need an x in it, right? Because I've got an x in both. And then I've got really 1, 2, 4, and 8. So our least common denominator will end up being 8x. All right, so let's take a look at what happens when I use this process. So here's our complex fraction, and we're going to multiply everything through by 8x. So I'm going to multiply 8x on the top all the way through and 8x on the bottom. So what this turns into is 8x times 3 over 8x minus 8x times 5 over 2. And then I've just got 8x times 5 minus 8x times 3 over 4x. Okay, so let's clean it up a little bit because this is not so bad once it's cleaned up. So 8x divided by 8x is 1, so that part just becomes a 3. And I can simplify this 8 and this 2 to 4 over 1. So that just becomes 4 times x times 5, which is 20x. Well, that's a lot nicer already. And then in the denominator, I have 40x minus, oh look, this x and this x cancel out. And then I've got 8 over 4, which is 2 over 1. And that just becomes a 6. Oh my gosh. 3 minus 20x over 40x minus 6. Do you see anything going on there? You see any relationships? Well, what would happen if, just for kicks and giggles, I took this and made it negative 2 times 3 minus 20x? Then the 3 minus 20x in the numerator and the denominator go away, and I'm left just with negative 1/2. This whole thing turns into negative 1/2. Crazy. All right, last example. Let's look at all the denominators and figure out what our least common denominator is going to be. We've got 1, we've got x, we've got x squared, and we've got x. Okay. Don't need to actually write it twice because we already have it here. So what's our least common denominator of 1, x, and x squared? If you said x squared, you would be a winner, chicken dinner. So our least common denominator is going to be x squared. Let's multiply it all the way through. X squared times and x squared times. So we've got 8 times x squared all over 1 minus 2 times x squared all over x all over 3 times x squared over x squared minus 5 times x squared over x. All right, so let's clean it up a little bit. This piece here is just 8x squared. Look, I've got an x squared over x. That's just an x, right? So that's just going to be 2x. And then in the denominator, I see here, I've got x squared dividing out an x squared. I've got 3 minus, again, I've got an x squared dividing by an x. So that's going to just give me a 5x. All right, so notice that we can write the numerator as 2x times 4x minus 1, but that doesn't really do anything for us. So writing it in either way is fine. Knowing that there's no common factors to get rid of is helpful, though.